Right, we're going to do some more AP review. Right now we're doing 2010 BC Free Response 3 is a parametric problem, so it's BC only, and it does allow a calculator because in 2010 the first 3 questions were calculator based. Currently only 2 questions usually are, but in 2010 it was 3 of them. All right, cool. So here's what we're given. A particle is moving along a curve so that its position at time t is x of t comma y of t, where x of t is given. So let's go ahead and write down what x of t is. So here's what we know. We know x of t is t squared minus 4t plus 8. Great. And then we're not explicitly given y of t. What we are given are dy dt and the fact that both x and y are measured in meters and t is measured in seconds. So we know the derivative of y. We do not know y. We know that it is t e to the t minus 3 all minus a 1, right? Cool. So A. Part A says, find the speed of the particle at t equals 3. So the first thing we have to know is we have to know how speed works, right? So the speed of the particle, right? So speed in general is the square root of x prime of t, quantity squared, plus y prime of t, quantity squared, right? So we already know y prime of t because we're given dy dt, which is the same thing. We don't know x prime of t, but we can find it relatively easily. You can, if you put x of t in your calculator, you can make your calculator derive this at 3. I'm going to make the argument that this is one of those that is so straightforward, it would be just easier to derive it yourself and get that x prime of t is a 2t minus 4. So once I know that, I would suggest, and you don't have to do this, but here's what I'm going to suggest because I think it's going to help us later on in other problems. I'm going to go ahead and put my x1t in my calculator as 2t minus 4, and I'm going to put my y1t as t e to the t minus 3 minus a 1. You certainly don't have to do this. You're under no obligation to do it. One thing I'll point out, though, is that putting different levels of your parametric equations in the same pair is a bad idea. So if you're going to put dy dt in as y1t, make sure you put x prime or dx dt as your x1t, right? Don't mix and match. Don't make this your x and this your y prime. That's not a good plan, right? These guys are a pair. If you're going to put the derivative pair in, make sure you put them in. So what I've done is I've put my velocity in essentially as my x1, y1. And the reason I did that is I can then, if I want, make my calculator find these values. I think this is going to be more useful later. I don't think it's super useful to you now, but a trick I showed you in a 2012 video was that if you put this in as your graph and you graph, right, and then you hit trace and hit t equals 3, then the x and y coordinates that will be stored in your calculator are these two values, right? So you don't have to do that, but if you if you put in your y1 and your y2, right, your derivatives, and if you then go to graph, right, and you hit trace, so I'm going to hit trace, and I'm going to hit t is 3, what'll happen is the x coordinate and y coordinate I'm given, well, it turns out that they're both 2's anyway, so that's easy. And I also could have figured that out by just plugging in 3. I'm kind of lazy. So I could have found x prime of 3 and gotten that it was 6 minus 4, which is a 2. I could have found that this was a 2, that this was a 3 times a 1 minus a 1, which is also a 2. Either way, so what ends up happening is that you end up getting that this is essentially a root of 4 plus 4, which is a root 8, or a 2.828 meters per second, right? Because it's speed, so meters per second, all right? And that's fine. So again, it's worth putting these in your calculator. I don't know that you need them right now to find this, but it's worth putting them in your calculator in general. For part B, here it's useful to have that. So for part B, I'm asked to find the total distance. So again, I'm gonna use the fact that I have this in my calculator, so I'm gonna leave that here, okay? Part B asks me to find the total distance traveled by the particle from 0 to 4. So when we talk about total distance is the same as arc length, right? So total distance equals arc length, right? So that's how you spell arc length. All right, so my total distance is going to be the integral from 0 to 4 of my square root of x prime of t quantity squared plus my y prime of t quantity squared with respect to t, right? Well, this is what I need to write out, and then I just need to spit out the answer, right? And since it's a distance, it'll be in meters. The trick is that since I've already entered these in my calculator, here's how I'm going to type this in. I'm going to go to Math 9, and I'm going to do function integrate, right? Square root of, well, I called this guy x1t, so I'm going to open the parentheses and do x1t squared plus I called this guy y1t, so y1t squared, close the parentheses, with respect to t from 0 to 4, and that should spit out the answer I want, which I believe is an 11.587 or 88, depending on if you round or truncate meters. So let's go ahead and walk through how to put that in our calculator real quick, just so you can see it. I've already put my x1t and my y1t in, so if I go to math, right, I go to math, I press 9. So what I want is the square root of, I go to vars, I go over to y-vars and pick parametric, I want x1t, quantity squared, plus vars over to y-vars, parametric y1t, quantity squared, close the parentheses, comma, with respect to t from 0 to 4. And I hit enter. And we're thinking, yeah, we're thinking, I couldn't tell if I hit it. All right, there we go, right? So it didn't take a short amount of time, but it's definitely not something you want to integrate by hand. Cool. So that was part B. Again, made easier by entering this stuff during part A, but sometimes you don't know that until after you've already done it. All right, let's move on to part C. For part C, we are asked, find the time, t, between 0 and 4 inclusive, when the line tangent to the path of the particle is horizontal, is the direction of motion of the particle towards the left or right at this time. Give a reason for your answer. Okay, so we want the tangent line to be horizontal, right? So if we picture what that means, right? So remember that slope, right? So slope of a tangent is always dy dx, which for our purposes is essentially y prime of t over x prime of t, right, in parametric. So if you have a horizontal slope, right, so the word horizontal, right, should translate in your brain to a slope that is 0. So what that means in our purposes here is that if this whole thing is 0, that y prime of t is equal to 0, but it's worth noting that x prime of t is not. Right? And the reason that's important is because 0 over 0 is an indeterminate form. So what I'm looking for is when y prime is 0, but x prime is not. Well, I can see pretty clearly that x prime is only going to be 0. So x prime is only going to be 0 when 2t minus 4 is 0, which is at 2. So I can tell that x prime is only 0 at 2. And y prime is a big ugly mess, and it is not 0 at 2, so I'm pretty safe. So what I want is I want to find when dy dt equals 0. So I want to find when t e to the t minus 3 all minus a 1 is 0, and when 2t minus 4 is not 0. That's what I'm looking for. So t can't be 2. Fine. I can solve for when this guy's 0. Now, an interesting side effect about being in parametric mode is that you can't second calc 0 the way that you normally would. So you have a couple options. For me personally, I'm going to opt to switch back into function mode. So what I'm going to do is I'm going to switch back into function mode, and I'm going to call my y1 x e to the x minus 3 minus 1, and I'm going to second calc 0. Unfortunately, you don't have all of the same options in parametric mode that you have in function mode. So what I'm going to do is I'm going to go ahead and go to mode, and I'm going to switch back to function for a sec. I'm going to go to my y equals and clear out whatever other junk I have, and I'm going to put in an x e to the x minus 3, sorry, sticky keys, all minus a 1. And I'm going to quit out of that. When I graph it, oh, it's probably not the nicest graph, so I'm going to zoom 6. Okay, I'm going to graph it, right? And when I graph it, I'm going to second calc 0. So second calc 0, I want this coordinate right here. Oh, I didn't do a good job. Hang on. Second calc 0, my bad. This is the problem with holding the calculator at an awkward angle. Okay, I'm below the axis, right? I was to the left, I go to the right, I guess again, there we go. All right, and I get a 0 that is 2.20794 and some stuff, right? So I'm gonna get that when I cheat, and again, this is stuff that I do for me, not for the AP, right? I get that t is approximately 2.20794 and some change, and it keeps going, right? Now, they're only going to want my answer to be to 3 places anyway, which is fine. But then they ask me whether I'm moving to the left or right at that time. Well, what that's going to mean is I need to figure out, so I'm gonna go ahead and call this, I'm going to call that A. So I need to look at what x prime of A is. Well, if I plug in x prime of A, if I plug in a number bigger than 2 here, I'm going to get something positive, right? You can find the actual number if you want. That's absolutely fine. Like, you can plug in x prime and you could plug this whole number in. It would be absolutely fine if you wanted to do 2 times that 2.20794 just to get an approximate value and realize that that's 4.41 and some change, right? That's fine. Doesn't matter. Minus the 4, my bad. So you can, I don't care if you want to find that this is actually positive, that's fine. Or if you just want to intuit from this that if you plug in a number larger than 2, this number will be bigger than 4, so therefore it's positive. So because this value is positive, the particle is moving right. Right, so what they're looking for here is they first want this t value, so 2.20 either 7 or 8, depending on if you round or truncate, and it should be in seconds, right, because everything's been measured in seconds. So they want this answer. When does it have a horizontal tangent line? So that's when. And then they ask, which way is it moving? I explain that it's moving right, and give a justified reason. I explain that moving right is because x prime of that point that I called A, right, and you could also just write all the coordinates, that's fine, is greater than 0, right? So that's my part C. All right. Next thing, let's do part D. All right, so for part D, oh my, there's 3 little mini Roman numeral type things. That's good times. All right, so for part D, there's a point with x coordinate 5 through which the particle passes twice. Find each of the following. 1, the 2 values of t when this occurs, right? Okay, so they're telling us that x of t equals 5 twice. First thing they ask us to do, little teeny Roman numeral number 1, is to find those 2 t values. So t squared minus 4t plus 8 equals 5. T squared minus 4t plus 3 equals 0. That factors nicely, which is not always going to happen, but yay, it did. So the 2 answers I get are t is 1 and t is 3. Okay, so that's the first one, Roman numeral 1. Okay, second thing, find the slopes of the lines tangent to the particle's path at that point. Okay, so the second thing they want is they want the tangent slopes, right? So when t is 1, right, my tangent slope, so I'm going to do m tangent at t is 1, should be whatever my dy dx is, evaluated at t equals 1, which would be my dy dt, evaluated at 1, over my dx dt, evaluated at 1, right? And you can make a calculator do that. I mean, there's nothing wrong with it, certainly. If you go back to parametric mode, it's actually pretty straightforward. Because again, you could actually use that trace function, right? So if you switch back to parametric mode, right? So if I go back to mode and I switch back to parametric, I already have this stuff entered in here. So if I go here, there's my parametrics. So if I go back to graph, what we saw before is if I hit trace and hit t equals 1, right? So if I hit trace and hit 1, it'll give me an x and y coordinate, right? So what I didn't have to do before, but I've done in a previous video, is that x and y are currently stored as x and y, right? So my x is currently stored as a -2, and my y is currently stored as a -0.864, blah, 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 right? And if you're ever not sure that's happening, you can check my logic. So if I quit out of this and I hit alpha x, now notice I can't use this button for x right now because right now I'm in parametric, so this button will give me a t. But if I use alpha x, when I hit this, you should see a -2 come up, and sure enough, it does. And if I hit alpha y, you should see that -0.8 and some stuff. So if I wanted to find this, I could just put that -0.8646, blah, 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 over a -2 by doing alpha y over my alpha x, and that'll do it for me. Now the cool thing about this, so I get a 0.432 as my tangent slope at that moment. And then if I do this at t equals 3, because that was the second spot I was asked, that would be dy dx evaluated at t is 3. Well, I'm going to use exactly the same trick, right? I'm going to do dy dt evaluated at t is 3 over dx dt evaluated at t is 3. And I'm going to use the same trick in my calculator. I'm going to go ahead and do, I'm going to go to graph, and I'm going to hit trace and hit 3. Well, now my x and y should be stored the same, and here it's not really worth it because they're both 2's. So if I find that they're both 2's, I'm probably just going to go ahead and put a 1. But if I had wanted, just to show you, if I quit out of here and hit enter again, it'll do the same calculation that I had just entered, the y on top of x, but now with the new y and the new x, which is a super awesome lazy thing. All right, last bit, Roman numeral 3, because this part D is long. Find the y coordinate of that point given that y of 2 is 3 plus 1 over e. Okay, so this is one of those first fundamental theorem of calculus problems. So when we look at part D, little teeny Roman numeral 3, right, We are given that y of 2 is 3 plus 1 over e. We are asked to find y of 1 and y of 3, which should be the same spot because they're the same point, right? It passes through the same x point. And we're asked to find that essentially using, and we're given, I'm sorry, and the other thing we're given, which I'll list up here, is that we're given that dy dt, which we stored in our calculator already as y1t, is t e to the t minus 3 all minus 1. So this is that first fundamental theorem of calculus question, right? So recall that the first fundamental theorem of calculus, which you're used to seeing with f's, is that if you integrate f prime of x with respect to x from a to b, you get f of b minus f of a. So the way you see this problem normally is you're given something that you can either integrate on a calculator or by looking visually at a graph with simple geometric shapes. You're given one of these two f values and asked to find the other. Well, the way you're going to see that in this particular problem here, right, is that if we consider that this equation right here is actually the same as y prime of t, because that's what dy dt is, right, it's y prime of t. If we were to integrate y prime of t with respect to t from, I'm going to go from 2 to 3. Since these are the same value, it doesn't actually matter which one of them I find. And that would give me y of 3, which is the value I want, minus y of 2, which is a known quantity, right? Because in the original setup to this problem, I was given y of 2. So I'm going to add the y of 2 over, and I'm going to get that my answer should be y of 2 plus the thing I'm going to make my calculator integrate from 2 to 3 of y prime of t dt. And that should give me my answer, which is y of 3. So this is the setup the AP needs to see. Now, how you choose to integrate stuff is on you. I would not integrate this by hand. This is not a nice, easy thing to integrate by hand. So what I would do instead, and you might want to play it safe, and you might want to call this y prime dy dt to be super clear that you are using their notation. So what's going to happen is I'm going to get this as a 3 plus a 1 over e, and then what I'm going to type in my calculator is function integrate, right? Function integrate of my y1t, because that's what I called my dy dt, with respect to t from 2 to 3. And I'm going to hit enter on this whole big mess of a thing, and after an awful lot of work, I'm crazily enough going to get that it's just a 4. So your answer ends up being 4. So again, what I'm going to do is I'm going to go ahead and hit 3 plus 1 over e, right? So there's my 3 plus 1 over e, plus math 9, right? So you go to math 9. I want to integrate my parametric y1t, comma, with respect to t from 2 to 3. And when I do that, I end up getting a 4, which doesn't feel as satisfying as it might feel if you got an ugly decimal, but it is what it is.